Welcome to the session. Today I am telling about the steady state simulation in the MODFLOW. How we can do the steady state simulation in the MODFLOW. How we can do the simulation in the MODFLOW for this data. These are the unit parameters which you should give initially, and the default parameters kx, ky, kz, storage properties. All these things you have to give it into the model, and later you will be providing mm, uh, the coordinates of the study area and specifying the boundary conditions and input parameters, and how to insert pumping wells and how to insert the observation wells, what are the data regarding the observation, all these things we are going to import now for these things. And first of all, you should open the visual MODFLOW. Create open new file. Valley problem. New file. Create new file. Save the project. If you want to write a description, you can write a description, and we are going for only the constant density saturated, and we are MODFLOW 2000 for length meters, time, day, conductivity meter per day, pumping rate meter cube per day, recharge per year. Okay, next, and give the kx value as provided in this table. Okay, import the site map. Just you provide this shape file, sorry, BMP file. Finish. Okay, and we have to give the coordinates here. Just zoom it by mouse and provide the coordinates here. X1 is 0, Y1 is 0. Okay, and x2 is 312.5, y2 is 170. And make it 312. Sorry, x2 is 312.5, y2 is 170. Shows a grid. Okay. 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 Yeah, we successfully created the grid here, and thereafter you can inactive the cells which are not necessarily outside the boundary. You can click on inactive cells and mark poly active. Sorry, mark poly inactive to make inactive. By making the right click, after clicking the left click, you just click right click, these cells will be inactive. Now these cells are inactive. Yeah, we successfully completed making the inactive cells here. Each thing, if you want to make any single polygon as suppose if you mark unfortunately by mistake, if you mark as inactive, you can make polyactive. Like this you can make it as inactive, sorry, active. And if you have been become some mistake, if you have done anything, you can save the model. And thereafter we have successfully completed we have designed the model grid, and we have done this, and the specification of the boundary condition. The first column is the specified flux boundary simulator using wells, one recharge well in each cell with a recharge rate of 275 cubic meter per day. 10 wells, one in each active in the left boundary, screen 0 to 60, and recharge in all the stress periods. 0 to 91.3, 91.3 to 186, 182.62, 273.9. For all these stress periods, the same constant recharge is taking place. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I think this cell is inactive. Yeah, say. And you can go to well, pumping well. There is some amount of flux is happening from this side to this side. So you just create one pumping well. You can add the well and click on this cell, and you can name it. Some recharge well, you can name it. Okay. Yeah. 0 to 60. Top is 60. Bottom is 0. Start day. First period is 91 0 to 91.3. Rate is what is the rate? 275 cubic meter per day. 91.3 to 182.6. 182.6 to 273.9. 273.9 to 65.2. Each period is known as a stress period. 0 to 91.3 is as one stress period. 91.3 to 182.6 is known as second stress period. In stress period, what will happen means there will be same amount of flux or pumping for one stress period. Like you can make it, suppose in this is for first 3 months there is 275 rate. Maybe in second stress period there might be some 300. It is saying that for 0 to 91.3 each day 275 meter cubes happen, and from 91.3 to 182.6 each day 300 meter cubes happen. What in the problem we have given means same period for same rate for all stress periods. I'm just saying what is the meaning. Okay. Yeah. Okay. We have created one recharge well. Suppose if we want to add another well, and it will be very much time taking for entering all the data. Therefore you can copy the well. Copy it and you can paste it. Just click it like 2. Okay. And if we want to edit the well, see here we have created 10 recharge wells with same constant rate, and you can check whether any change is there or not. Okay. And what in the problem they have given, the last column is constant head representing the reverse of head 50 meters. Boundary, you can go to constant head boundary. Constant head means like perennial river. In perennial river, the total in an year flow will be taking place in whole year. So maintaining the constant water level. Constant head means constant water level. Suppose in sea water also will not be varied that much. It will be holding so much time it will take to vary. I mean, if the variation also very negligible. So, I mean, if there is any sea, if there is any perennial river, then you can make those areas as a constant head. Assign line. Yeah. Start time day and the end time day. 5.2. 50. 50. Okay. Hmm. Later. And we have completed this as okay 50 meters. An initial head 50 meter in the last column and rest all 54 meters. Initial head is of 54 meters for remaining blocks. For remaining blocks, initial head is 54 meters. Go to initial head. Yes. Assign polygon. Create new zone. Okay. Initial head is initial. Okay. Successfully I assigned the 50 meters as initial head of these cells. And later, now we completed this one. Now we are going to give the values of hydraulic conductivity 40 meters per day for all three zones. Three zones means kx, ky, kz. Sorry, three zones. We have to create different zones, and later we should get 40 meters per day as the permeability. I mean, if you work for whole basin, then there will be different areas. You should give different. I mean, you will be having some different permeability values. So, if you want to provide different permeability values for different zones, therefore you have to create some zones. Polygons. Suppose you are thinking that this zone is having some different type of permeability. Kx is okay. Suppose it is having some type of different permeability. You can take, if you want, you can consider other zone also. Database. Okay. Yeah, if you see that this 40 blue color zone is saying that it is having the 40 meter per day, and the white color zone is of the 10 meter per day. Like that it will be assigning here. Polygon. Suppose if you consider that this zone is having some different type of permeability. New zone. Suppose 20. Okay. And you can consider like this. And later the specific yield you have to consider. Properties, you can save the things and go to storage. Polygon. Point 3 of specific yield. Specific storage is 1 is minus 5. 5. Specific yield is 0.3. Okay. Okay. We given the properties of the storage and storage properties and transmissible properties of the aquifer successfully. File, save. Now we are going to proceed with pumping wells. See two pumping wells, PW1 and PW2. They have given the X, Y and coordinate and screen bottom and screen top and discharge also they have provided to you. Well, pumping well at the well. Suppose you don't know that X where is X 156.25 and 85 you don't know. Suppose you just click on somewhere in a study area, just click somewhere and it will ask you to enter the coordinate. Therefore you can enter the coordinate here 156.25 and Y coordinate is 81.85 and well name is pumping well 1. Okay. 60 meters 0. Start day is the first stress period is 0 to 91.2. 0.22 sorry 91.3. Okay, 182.6, 273.9, 365.2, 91.3. First stress period is 1500. Second stress period is 1000, 0, 1500. Okay, and thereafter another well, add another well somewhere and give the coordinates 81.25 and 35. Pumping well 2. Okay, enter the screening 91.2. Okay. 182.6, 273.9, 365.2, 2000, 1500, 1500. Okay, we have successfully created two pumping wells. Now we have to create observation wells. Wells head observation wells. Yes. Just add the observation well somewhere and we have the X coordinate and Y coordinate 131.25, 65. Well name is observation well 1. This is O. Okay. Observation well 1. Okay. Screen ID is A and 30. Okay. Screen elevation is 30. Now we have to import the data of this observation well the load observation item takes you can load the observation item. Insert data. You can find one Excel here. Open it. Maybe you can find one. This one. Okay. You can find one text file. Time is column number 1. Head of the observation 1 is column number 2. Make it as 1. Okay. Okay. Now we have successfully entered the observation data of the field. Okay. Okay. See here the observation well is created. Now add another observation well here. Observation well 2. What are the coordinates? 81.25 and 55. Okay. You know the screen ID and you should import that file. One. Observation 2 data is column 3. Use column names in the line as well. Okay. Okay. Now we have successfully imported the observation well also. And you can successfully save the file. Okay. And if you and thereafter you can go to main menu. After this you can run the model and go to MODFLOW 2000. You can see the solvers, types of the solvers used here. Okay. And if you want to change this parameter, you can change if you want. And run the MODFLOW 2000 and the zone budget. Translate and run option. It has been successfully run. You can close this and go to output. See the observation, head, water table head, how it is moving 68 to 66. You can observe that here, the observation well. Okay. And thereafter go to tools, graphs, time series, head. You can see the zone budgeting, the recharge on the wells and pumping, all these things. Before this, go to main menu, go to input. Now we will add the river here. MODFLOW river, we will add some river here. We will assign this boundary as a river and this boundary as a river. Just assign by single field. and you need to fill all these things. 85.2. What is the river stage? 25. River bottom, river bed thickness, river bed conductance. Okay, and after that river. River stage, you can assign the river stage also here. Okay, we have successfully assigned two rivers here, and if you want to arrange the single, just arrange. Okay, that's all. You can arrange the cell as a river here, and thereafter you can save the file and just run the model once. Run, run, translate, and then close output. See here, see the RMS error here, 779%. It is very more. You have to calibrate these things by changing the permeability values, all these things. You can calibrate during steady state. You can calibrate the model by using the permeability value, and during transient state, you can calibrate the model by using permeability as well as the storage parameter, like specific storage, specific yield. You will be using all these things. And these are the water table contours. You can see here how the water is flowing in this direction, from higher head to lower head. If you want to view this model in three-dimensional view, you can view this model like this by pressing F2 or like that. Pumping wells, you can see head observations, you can see conductivity values, you can see. And if you want to observe it in like three-dimensional manner, also you can observe like this here. See how you can observe this. You should play with the MODFLOW like this. You can visualize many things here. Okay, that's it. You can visualize all on, and you can visualize the values. What is the model X and what is the model Y, the cell bottom, cell top, cell techniques, what is the Kx, what is the Ky. All these things you can visualize by moving the cursor here. Okay. You can see percentage of the volume from the constant head and from the wells. I mean in and out. I mean the percentage of the water. I mean the volume of the water enter into the system and volume of water out from the outer pumping out from the system. All these things you can view here. If you want, you can export the layer. All these things. See the velocities, how the things, I mean flow lines, velocities, all the things you can map it. You can see the mass balance here. See the, I mean from the constant head, from this constant head, how much amount of water enter into the system in terms of volume. How much amount of water enters from the wells, seepage. All these things you can visualize here. From the river leakage, all these things. From the wells, how much, the rate, this is the rate, meter cube per day. Those. Just play with the MODFLOW software. You will be knowing many things from this lecture. Thank you.